Welcome to today's live stream. Sorry for the delay. A little bit of technical difficulties on our side, but on tonight's live stream or today's live stream, depending on where you are, we'll learn how to build and deploy a private invoicing system on COTI. This session will show you how to keep invoices fully confidential on chain while still managing payments end to end. Leading the discussion is our developer, Henry. And of course, I'm Calvin, the creator. All right, handing it off to you, Henry. So, what are we doing today? Tonight, in simple
Hello
terms.
everyone, I'm Henry. I'm Developer Relation at COTI Foundation, and I'm really happy to be here today to introduce you private invoicing system.
Nice.
Okay, let me share my screen.
Oh, so I do have a question on the invoicing system. Will this be for from wallet to wallet, or can this be on chain to off chain?
It will be on chain.
On chain
So
to on chain. Okay.
yeah, on chain. So basically, people will create an invoice on chain, and recipient can pay that invoice, and we update all the data on chain. And the beautiful of it is only the issuer and the recipient can see the invoice detail because it's a
Hmm.
sensitive information. And another one, and they cannot see the information, the detail of invoice. And that record of we will using the private layer of COTI blockchain.
All right. Good stuff.
Okay, wait me a little
Hmm.
bit. I will share my screen.
Hmm. Hmm. Ooh, going on to them, I suppose. But how are you, Henry?
So I'm good. I'm good. How are you?
Doing well. Doing well. Yeah, there's a little bit of technical issues from our side back, or from Restream side, just now. So we didn't get to catch up. But yeah, dinner yet? Ooh. And share the screen and should be here.
Okay.
1 second. Hmm. Are you sharing your screen?
Yes. Can you do you see my screen?
I do not see your screen yet.
Yeah. You have to approve it.
Okay,
So do you see my screen on the left side?
there
You
we
have
go.
to
Gotcha.
approve it. Okay. So I will show the chart. Okay. So today, we will building a confidential invoicing smart contract. And in the world of blockchain, privacy is a major challenger. So most on-chain transactions are public, so which is not ideal for business operation like invoicing, where financial details should remain confidential. So this
Of course.
guy will walk you through the process of building a private invoicing smart contract, and that leverages advanced encryption to keep invoice data private while still using blockchain for settlement and verification. And I will show you the flow first. So to better understand how the different component of system interact, I visualize the entire process with sequence diagram. This diagram illustrates the flow of action. We have three action here: issuer, smart contract, and recipient. So issuer is a person or an organization who will issue the invoice. Recipient is a person or one organization will pay the invoice, and smart contract is in the middle to handle all the algorithm.
Interesting. Okay. All right. So the issuer will be the seller, and recipient will be the buyer, right?
Yeah,
Okay.
you can think of it. Maybe issuer can be a company want to hire freelance and they can
Yeah.
issue an invoice. In the reverse,
Well,
issuer will be the freelance want to
yeah.
share service to organization and they
The
issue
issuer will be
and
freelance,
resident
and
is the
recipient will be
organization.
the
Yep.
the client. Cool.
So
Gotcha.
it start by the issuer. So they start by they will issue the invoice, and when they issue the invoice, they will add the parameter recipient, which is the one will be paid. The invoice ID, uh, description, and amount. But in here, we will encrypt all the data. So the smart contract will validate the encrypt amount, create and store the new invoice, and emit an invoice issue event to issuer. And then the recipient will pay the invoice with they will input the invoice index and payment amount and pay the invoice, and they will encrypt the payment amount and call the pay invoice function. The smart
Okay.
contract verify that caller is the correct recipient that the invoice haven't, and the invoice haven't already been paid. So it then updates the invoice started to paid and emit an invoice paid event. So in here we will validate two things. First, we want to validate only recipient that's on that invoice ID can pay the invoice. So another one cannot pay that invoice. And also we will the amount of the pay will be encrypted, so nobody know the amount of the invoice. So let's say
Except for
you
the issuer and
yes,
the
only
recipient.
issuer and
Yeah.
recipient can know.
Okay.
And
May I ask what currency will it be paid in?
um, currently I only add COTI as a native
Okay.
token, but it can expanding to another private ERC20 token. So we can issue a new private ERC20 token and apply the same flow, but it will be another step here. So if you're using the private ERC20 token, you have to approve first. So we
Okay.
have approved step to allow the smart contract to use the token on the recipient wallet. So it will be another step for approve the token, and then you can pay the invoice. So it will be another
Gotcha.
step here.
All right.
And and then we have the viewing invoice here. So the issuer and recipient can cross in get invoice function only. So when they get the invoice function, the smart contract check if the caller is authorized. So and if authorized, the contract returns the encrypt invoice detail, which the
Mhm.
user can then decrypt or change to view. So only them can see the data. So we have the three flow here: issue invoice, pay invoice, and get invoice detail.
Okay.
Is basic flow. We will try to create a smart contract. So I don't want to start from scratch. So I will show you our a repository of COTI contract.
Of
So it
course.
so it's a repository of the COTI contract. It's compiled a lot of smart contract that are written by COTI Foundation. They also have the config of head. So you can use a head config here. And also they have some test file already written. So I will start from here. You can see on this we have a contract for onboard account. So it's a process in COTI blockchain. So to encrypt the data, people have to onboard to COTI blockchain first and get the AES key. So with the AES key, user can encrypt and decrypt the data. And they also have the token smart contract with private ERC20 token, private ERC, and private ERC 721. They also have the data privacy framework loss fluidity. So you can see here it have using some um, encrypt feature here, so private feature here, and that is. So I will start from here. So I will clone this using first I copy the link and I open the terminal and go to desktop and clone this. But I already do this on my computer, but
Mm-hmm.
If you do it on the computer, you just need to git clone and run the cd to the folder. Oh, I have a lot of COTI here. No, I want to go to desktop first, and, and then git clone and with the name COTI contract. I should okay something like that.
So, may I know what the advantages of using COTI's pre-made contracts rather than building your own?
I will build my own contract with I will start from the repository of the COTI version, so
Hmm.
it will take a lot of easier. So you can see another smart contract, and you can also use a hard config of them.
Hmm.
You don't need. I think I misspelled COTI contract. New. I did clone with the name COTI contract slideshow.
Contracts. Wait.
Okay, but never mind. Is I have a lot of here, but I
Oh.
join with COTI contract. I think code dot. Yeah, it is okay. So uh, I have choose invoicing here, but I will delete it and start again. Delete private delete. Okay, so when clone this repository, you have the contract folder. So in the contract folder, you will have a lot of contract example. We have token on board, most smart contract, and I create a new folder called invoicing to create our smart contract here. So I will new file and I will give it a name like private invoicing dot strong. Okay, so the private invoicing smart contract will allow user to issue, pay, and view invoice. Uh,
Hmm.
and we have some key component. First one we have uh, first we need to let's see, we have to uh, clarify the Pragma version first. So Pragma Solidity version first. We use it by using Pragma Solidity, and I want to use the version 0.8.90. It will be the our Solidity version, and then I will import the MPC core from utis folder. So we have utis here and MPC core also shown here, and I want to inherit it. How I will import the utis MPC MPC core dot so core let me disable the Vietnamese keyboard. Okay, so we have import the MVC utis MVC core dot json. Okay, and then I will add the MIT license, and we will start the contract. Contract will be named private invoicing, and we start from here. So let me zoom up in a little bit. So we will start with the struct. So struct with the we have to start invoice. So because invoice is a complex identity, so we need a struct to store all the data of the invoice. So with the invoice, we have address. So issuer, so we need to know in the invoice, we need to know who is issuer and who will be a recipient. Recipient.
Okay, so this is the invoicing part itself, right? The information that you need to put into who to issue, who the issuer is, and who the recipient is. Is it identified by their wallet or?
Yes, because it's identified by the wallet address, so it's
Okay,
by
cool.
address. we have address issuer and address recipient.
All right.
So in here we have to define the type. So we have to type address, and we have the variable name issuer,
Mm-hmm.
and then we have a string with its invoice ID, invoice ID, and um, in Solidity it have some of the type like address, unsigned integer, and string. But in here we have some special type for encrypt data. So we have CT string is encrypted invoice ID. So it's different than normally Solidity have string, have you an integer 64 blah blah. But currently we're using here is CT string is
Okay.
encrypted ID, and we will need the description, because in invoice you need description to know what it is, right?
Yeah, like the services you're providing or what you're invoicing for.
So it will add
500 chairs or something.
description, and we will need the amount, but we want it to be encrypted too. So we will add to the 62 amount of the token
Oh.
encrypted, and we also need um, status of the invoice. So we want opponent type to be it could be is best or not. So okay, I think it is a basic infrastructure of the invoice. So invoice will have we will know the issuer, recipient, invoice ID, description, the amount of the invoice, and the status of the invoice. And now we will mapping them uh, with the invoice ID, invoice public invoice. Okay, so we have invoice here, and uh, we will need integer, unsigned integer to store the invoice count, so we will know uh, how many invoice we have here. And that is, I think, is we preparing enough data, and we'll start with the first feature, the first function. So call is function issue invoice. Okay.
Mm-hmm.
So is the function, this function uh, will issue a new invoice, and it will take four parameter. So first it will need the address or recipient, right? So the issue or we don't need the address of issuer because issuer will be the man who calls this function. So we need to add the recipient address, and we need uh,
Recipient
same,
is the
yeah, it's the same as a drop. So we need we need
is the
invite
buyer. Okay, cool. Right.
ID. We need string collator. We will need description.
You said that we don't need the wallet for the issuer
Issuer, because
because
issuer will call
in
this.
this function, only in this function.
Yeah, because
Okay.
issuer will call the issue invoice
Yeah,
function.
yeah, yeah.
So we already
Right.
know his address. So
Yes.
we need the issuer to input the recipient address, the invoice ID, the description, and the amount for us.
Okay. Cool.
Later amount. Okay, so we take 0 4 parameter, and it could be external. So that means anyone can call this. And we need to sorry, the 62 will be enough. Later amount IT. So, okay. And first we want to convert the input amount to grab it. This, then we will then to user text for storage. So is something when we use a smart contract, we should put some command. So later we can see it and know what we was writing, and another can see and know what we want to write here.
Mm.
So first we want to convert the input amount to garbage text. So we will do it using the MPC car we import here. So with MPC car, we have MPC car dot validate cybertext, and we get amount here. And also we have 62 memory encrypted amount
And
equal,
this part will encrypt the amount
yeah,
requested. Okay.
it's,
How much money we're asking for?
but combine with, yes, and it take two parameter, amount GT and the recipient recipient. Okay, MBC enter integer encrypted amount output combine amount GT with amount GT. Okay, recipient. Um, and then we create invoice. I think we have all the thing we want, and invoice count. We have mapping here, so this will be you can think it's like array. So we have invoice 0, invoice 1, invoice 2, and this invoice count will be increased. So in that case, you can put the invoice count here. Invoice count. So in that way, we can create arrays
Yeah.
in point.
So invoice count is the basically how many invoices has been sent out by the buyer, right? By this
No,
seller. Yeah.
by the smart contract. So it's
Oh,
calculate all the invoice in the smart contract issued by a smart contract. It's not by it's a global. It's store on chain and it's count all the invoice issued by this smart contract.
okay.
So we have the invoice and we need to configure all the parameter here. So we have issuer will be the message sender. So message sender is the one who calls the contract, and we know who it is using the function message.sender. And the recipient will be the recipient here. So if user configure the recipient with the invoice ID, I will copy first. It will be faster. Will be invoice ID here. We have description. This will be this description, and we have amount. It will be the encrypted amount. Uh, and that because when the invoice just created, it will be full, meaning uh, is haven't been yet yet. It needs the buyer to need to pay every 100%. Mhm. And I think that's enough. After we create the function, this function issue event, we need to emit an event. So it's basically is like notification. So
Mm-hmm.
or when anyone calls it function, it could emit an event and the front end and another platform and can get the signal and start doing things. So
Okay.
we, we will create event. We have to create event first here, and then we declare the event first. So we have the event called is invoice issue invoice issued, and it will show the unsigned example to see indexed invoice index address indexes sender issuer and address and indexes. So I think we just need three parameter. So
Okay.
if if we emit the event after the function call, if we emit the event that has three parameters involving this, we know that involve it's involve type. So if the involve index is what's involved and who is issuer and who is the recipient.
Okay.
Uh, and then we will emit an event here, invoice receive, and we put first invoice count. So we know it will be with event invoice ID 0 will be is issue, and message sender is the issuer, and recipient is the recipient. Okay. And after that, we need to increase the invoice count. So
Ah.
when it's the first time invoice count will be called, it will be invoice 0. But next time it will be invoice 1,
So
invoice
it's
2,
+1 and +1 every time it sends. Is
invoice.
this best practices or is this necessary?
That is necessary.
Okay.
So it will be makes the invoice is unique.
Yeah. It means because if there's no count, then it can send one after another, and you won't know which one's the most up to date one, right?
Yep.
Yeah.
Okay, this function should be good. So let's try to combine it. Okay. So I think we will try to combine this part first to make sure it don't have issue, and we will continue with the next function. So we do it by using npx attack compile, and is on the contract invoicing private. Oh, not for that invoicing private. Oh, we have to save it first. Private invoicing invoicing dot form. Oh, we have unexpected error. Content I module. Oh, it's not fine. We have set it private in private invoicing. Private invoicing. Link and delete as on my contract invoicing and invoicing. Okay, error to unrecognize positive. Which is not in content. Let me check. Oh, let me check with this ABC also. So, this concept. I think I will finish another function and come back with the compile at the end. Okay, so we go to the second function. It called pay invoice. Pay invoice.
Okay.
Okay,
So
so I tried
um
it and have some.
so basically the invoice part is sending the invoice part is has already been done, and now
Yep,
this is for the buyer to be able to send money to the seller
yep.
to
I
make
had.
this short.
I'm using the current most version with not support by had. Uh, so I think I will fix it. Let's I will finish the pay invoice function and then I come back and fix this issue. Don't worry. We have the function pay invoice. So the second function is pay invoice. It will basically pay in invoice, and we have to ensure that amount is validated and also encrypted. When the um, where's my diagram? Okay, when the recipient receives the invoice, they can pay the invoice, but the invoice amount will be encrypted and no one will know the amount. And after they pay the invoice, we need to check, verify the color is recipient and the invoice is unpaid. So he will not pay the unpaid invoice, and then we update the invoice status to pay. So that's something we need to do. So with the pay invoice, we will need two parameters. First, we need to know what is the invoice ID. So we do need the invoice index and the ID is 62. The payment amount external. So it can call by anyone outside within external. So first we will uh, need to store it. V equal mm, invoice invoice index. Okay, and store it. Let's enter. Store it. Okay, we need to require. We create a invoice is temporary variable called inv is will be invoice index. So let's say if I want to pay it for the invoice ID 0, it will be invoice 0, and then I need to check the message sender. This message sender calls the pay invoice will be the recipient of the invoice. We will do it by using the require function of solidity. So we need to check if the message sender equal env recipient, and if not, we will throw the error not authorized. Okay, not authorized. Okay.
Okay.
Then we need to check if this uh, and if this invoice is paid. If it's paid, we will show the error already.
Oh, hello, Henry. I think we lost you a little bit. Hello. Hmm. Henry dropped. Well, it's on. Should be fine. Henry, you're back. You dropped just a little bit.
Oh, sorry.
It's okay.
So we need in event here to it's the same with invoice issue. We need the event invoice paid. So when user calls a pay invoice, it will emit invoice that emits event that invoice has paid, and anyone can know us.
May I know if so I'd like to know a little bit about how it validates if it's paid or not paid. Um, is it constantly checking if the payment has been done, or is there a time?
So we have two ways to check the invoice paid. The first one is the third function we will writing here. It's called get invoice. So after we writing the get invoice function,
Mm-hmm.
you can put the invoice ID, and you will know that the invoice uh, is paid or not. And also when invoice was paid, I will emit the event. So invoice paid emit event is like notification, and
Okay. All right.
front end
Yeah.
can catch the back end can catch just event, and we will update on our database or something.
All right. So like a notification
Back end
to mention
server.
to the issuer that the invoice has been is
Correct.
fulfilled is paid. Okay.
So that's why we need the event to know
Mm,
to notification when something happened. So
cool. Cool.
when someone calls the issue invoice, you could emit the invoice issue, and the backend can know and update.
Gotcha.
And with the event invoice paid, when someone pays the invoice, anyone can know us. Normally, we will do it by using our backend. So our backend like subscription to that smart contract. So if some event was fraud, we know that, and we update our database, and user can see on the front end that the list of the invoice. When you create a new invoice, the backend subscription to smart contract knows the event, and they update to the database and show to you the user. When someone pays the invoice, the smart contract is subscription to the smart contract. They know the event, and they update to the database and update to the user. So, uh, can you catch up on that? So basically, we have something here to.
I think I can. I think I caught that. Um, yeah.
It basically we have the backend server, and the backend server with subscription to the smart contract.
Okay.
So when something happen, let's say some people create a new event, create a new invoice. The smart contract will emit an event and send back to the backend. Backend will know us, and they will update to the database, and then show to the front end to user. So basically,
Gotcha. Thanks very much.
okay. I'm finishing the event here, so we do need
Cool.
the info index and the message sender. So it's the people who paid the invoice. And finally, we need to write the get invoice function. So with the get invoice function, is to be you only need one parameter. It's the invoice index. So it's invoice index, and it's a view function.
Hmm.
So view function is like uh, user request and is only return the data. Is not change the data on smart contract. or using view return for that uh, to check the data. So with these two function, when you call it function, it will change some data like of smart contract, and it will get gas and will get invoice function. It only get fetch the data from smart contract only. So we have to define uh, the structure of the data first. So in the structure of the data, we will respond to user. We will send user the issuer. So when user puts the invoice ID, we show them who is the issuer. Uh, I think it's basically this structure.
Yes,
I
the
will
front,
copy
yeah,
it.
the top,
Yeah, we
all the
have
things that's needed.
address string. We need to put it memory to memory and string memory no memory declaration memory no and pit. Okay, that is. And I will create temporary storage and v equal to invoice not invoice invoice instead. Okay, so it's required. So in here we need to check if message sender, the one who calls this function, is the issuer or uh, the message sender is the recipient. So only recipient or issuer can call this function. And if not, we will throw the error not authorized. Okay.
Okay.
So, and finally, we return the data return iv dot issuer inv dot recipient inv dot description description and inv dot amount and finally inv dot fit. Okay, and that is we have so far finished the smart contract. Now we will try to compile and make sure it's work. After that, we will write a simple test file. But
Hmm.
I think I will use the AI. We will write code the test file. So the
I was
test
gonna ask if this is if this is vibe codable.
yeah, basically you can write code it if you have input enough data.
Okay.
So basically, when you send the AI a lot of private smart contract or COTI blockchain, I think they can create that smart contract too.
Hmm.
Uh, but it had to enough data and had enough direction from prompting. I think it can do it.
Cool.
Uh, I think that is. Now I will try to compile it again and see. I see the know that it will be full, but we know what's the error and ask the AI to fix it here. And new.
Oh, and here comes the vibe code part, I suppose.
Yeah.
Do you have a favorite AI tool to use?
It's I use this wrong. I use the wrong. I had compile. Sorry.
Oh,
Is that compile? It's not take the parameter. Somebody. Oh, we have we have an issue here. Is will when you define the struct, you
mhm.
have to use the Do not use a semicolon.
Oh,
I think
it's
it
quite a
will.
bit.
I'm saying it is fixing for me or not.
Oh, you're looking
Okay,
for it to fix for you.
we have the issue
So
here. It's
make sure.
editing. Oh, it's editing my file.
Oh, fixing your mistakes for you. So it's not semicolon, it's comma.
Yes.
Interesting.
Return different number is written. Oh, I think we have some.
Compilation failed.
Let me see. We have one, two, three, four, five. One, two, three, four. So is the wrong here is we type a different number of argument in return statement than in return declaration. So in here we had one, two, three, four, five, six. But in here we only had one, two, three, four, five. That's me what I'm missing. So I is here. I be recipient. I'm missing the invite ID. Human. One time. Correct.
So if AI wasn't here, would you have to spend hours just looking
Yeah.
back at your code? Yeah,
Clear. And I
I remember taking Python classes.
I try to combine. Yeah, we combine successfully. Uh, Now we combine it. We try to let's go to have me deploy it. So if we use and we can have to deploy, but I want it to do it for me.
Ideally, it'll do it for you.
Take a little bit long. Have me deploy. Do I need to specify? I fix this. It's one to fix my previously error, but I already fixed it. Uh, I wait it. Waiting. Yeah, confirm. Yeah, I try. Ah,
Yeah.
yeah, it's compiled again. So okay, compile successfully. So we try to fix my previous error, but I already fixed it, and it's check again to confirm that we add the variable name in ID. Oh,
It's taking credit for you. It says that that I fixed it,
let's.
not you fixed it.
I think I should let them fix it. But, okay. Okay. So to deploy, we will need deployment script. Uh, so you can see here we have a contract directory script. So it's create a script file to deploy. Look, hmm, awesome. So in headhead.config, we can see that we're using COTI testnet with version 0.8.19. Oh, 49. So it's we have to activate here, so it has the same name. So is we have to we want should I will specify it. Okay, it's green. So previously I create artifact called private invoicing, and it has the same name. So it has it want us to replace private invoicing with one of the option. Now is we run the script to deploy, combine it, operation.
What's the issue now?
Yeah, I think it's try to deploy all smart contract. Let's see. Yeah,
Oh, it's trying to deploy. But there is an error, right? Successful unsupported operation.
yeah. I think I will guide. I think it has the wrong direction, and I'm trying to deploy it. I think I cannot trust that. Let me guide it so it can be smarter. On the AI, I think it's go on the wrong direction here. So I will ask it to follow uh, read the ABC test dot fine. Test not yes. Fine to know how to deploy script. So previously I write a test file here.
Hmm.
It's and it includes the deployment.
Ah, and this is a previous test that you made
Yes,
for invoicing.
yes. But I want now I want to use the AI to do it for me. I want to check if the AI can do it because it's that.
You basically is you're letting AI copy your homework.
Yeah. Just issue. Now we will try again. So issue consent. Right. Oh, the test file is a little bit long. I don't know if we have enough time to explain all the test file. I think I will only only check only show the concept of it. So after we write as a smart contract, we need to write a test file to test if it's working or not. So you can see here in the test file, in a lot of tests for our smart contract with private ERC20. We have private ERC20 test group here, and I written abc.test. So it's a private invoicing test. So what is the testing file do? So first of all is issues issue an invoice. So we first we uh, deploy the smart contract. After deploy the smart contract, we create a new invoice on with invoice ID 12345 description. We will test invoice and the amount will be 1000. And then we encrypt the value. After encrypt the invoice ID value, encrypt the description value, and encrypt the amount values, we call the call the issue invoice function we create on the smart contract. So we will be using the private invoicing connect to the issuer. I forgot. I forgot. We will have a for entity. So we create an issuer and a recipient, and then we connect to the issuer address and call the issue invoice. Paste the parameter, recipient address, invoice ID, invoice description, and invoice amount, and then we have that transaction. And because it could emit an event, we will uh, get that event and know what is on that to make sure that it was issued. And is the test for should issue an invoice. After that, I write the test file to create should buy an invoice. So in this, we will need to using the issuer to deploy first, and then uh, the payment. Okay, so we encrypt the payment, and then we connect to the recipient, and the recipient we call the function pay invoice to pay the amount, and we check if the uh, issue pays it fine it, and we look the invoice it invoice paid. After that, I write the tag for should not pay an already paid invoice. So with test file, I will check if the invoice was paid, it cannot be paid again. So it's the same thing, but when the recipient try to pay the invoice, it will get the error. And finally, we have should not allow unauthorized user to get invoice detail. So with this test file, I checking if another one who not authorized like its issuer and recipient call the get invoice detail, it will get the not authorized and instruction will be revert.
Okay.
Okay, available is not available.
I
That's a limit.
AI is not able to replicate.
I think it's going to close. Okay, let me try to use that file. In the meantime, we wait. Deploy the contract.
So we're working through your test file now
Yeah.
while the AI works.
Oh,
Cool.
it deployed successfully.
And
Oh,
this
I
is
know that if we take the AI with the right direction and the right data, it can do it, man.
wait. So this is the AIs
Yeah. So,
private invoicing.
no,
Okay.
the test file is by me,
Oh,
but
right. Yes.
I, I, I asked the AI to read my test file.
Yes.
Based on that, change your script of deployment, and it's and it worked it perfectly. We have the contract
Nice.
deployed
It
to.
copied your homework and it works.
No, it goes. So that means we can like create a lot.
We can move on. Nice.
We have the small contract here.
And
Let's
test the smart
see.
contract, see if it went through, and it did. Success.
Okay, so it's,
Transaction. Yep, it's
yeah,
there.
50 seconds ago, they it create a smart contract. So we have smart contract on COTI testnet now.
Nice.
But now I will run the test file to check if it work. So date had test uh COTI test file invoicing and ABC of test. Oh, private
Should
invoice.
should issue an
I,
invoice. Hard hat.
it removed my artifact because I had to compile again. It removed my artifact. So basically, when you compile the contract, it will create an artifact folder. So it have
Okay.
artifact, and you use the artifact and to checking. So
Okay.
it's the artifact we need for the backend to integrate with the smart contract. and I think it's Previously, the AI using entry is had clean. So with this command, it will clean all of my artifact. I had to. Uh,
So it can't find your smart contract.
it's not find my artifact. So the contract after compile, it will
Yeah.
generate artifact, and but
Mm.
it clean it. So I had to compile again. It's not a
Okay.
profile. I think they compile it. Nothing. Oh, I have to change something. Wait, six. No, it's on here. Let's see if we can change it to this. Uh, we just create a private invoicing. I forgot the name. Private invoicing. Yeah.
Your
Okay.
private invoices.
I,
Yeah.
I want to know if I use a capital I or not.
Yes.
Private invoicing. And
Yeah. So usually with invoices, there's like it's about 14 days, some depending on the type of invoice. 14 days before it's not valid anymore. When you issue an invoice, is there a time limit for the buyer to send money to
currently, I
pay?
don't have this, but I can add it. It will be another thing on the struct. That question private invoicing. Here we have struct, and we can add another like time.
Okay, so it is another. If there is no time, then it is forever.
Yeah, correctly.
Okay, all right.
Let's come back to the test file and see if any ABC private invoicing, save here. Okay, we try to run that again. So it's combine. It comprises solidify. After combine, it will deploy. So yes, after deploy, it will run all server test file here. So firstly, it's run if user can issue an invoice, and then it will run to should pay an invoice. Yes, it's passing passer test and should not pay an already paid invoice. Should get invoice detail. So issuer and recipient can get invoice detail. And finally, it user tag not authorized. It's capitalized. Ah, so in smart contract, when the user is not issuer or recipient,
Uh-huh.
I will tell them not authorized. But on the test file, I show not authorized with not capitalized. Not authorized. So again,
Yeah, it is so small.
but it on the code, so one will be on. You cannot change that.
Yeah.
If we try again, if we combine the smart contract, and it will issue an invoice. Now it can pay an invoice. Should not pay an already paid invoice. Okay. We will think.
Pay double. That's good for the issuer. That's okay.
Yeah.
If for the issuer, no problem. Right.
Should get invoice details, so issuer and recipient can get invoice detail, but another one cannot. And we go to the final test. Yeah, it's passing. So it's not allow unauthorized user to get invoice detail. Okay, so so far we have deployed the smart contract of private invoicing, and we have finished smart contract, compiled, deployed, and write test file and run through all the test file. Do you have any question, Kevin? And also from the comment section.
No questions so far.
Mhm.
Uh, I've been asking a lot of questions like this.
Yeah.
So, yeah, I'm good on comments on my side. On my side, uh,
So I think this you can always start with the COTI contract repository if you have a lot of things that you can learn from, and start writing your smart contract from here. And I also will boost my code into repository and will send the link to you.
all right. But I do have a question though. So, if you were to do a like issue the invoice on chain and pay by, I don't know, bank transfer, for example,
Mhm.
would that be possible?
Currently, it not possible because it's hard to integrate those two. You need an oracle or something that needs to oracle to connect between on-chain and off-chain. But I
Yeah.
think it's kind of interesting perspective. We can do a manual update for the issuer to update the page status uh, at the moment. So it will be like, I think, the simple solution for those case. So let's say if you banking from the issuer, the recipient banking from the issuer, the
Hmm.
user can go into smart contract and update the invoice to page status. Mm, but it could be manual. If you want to be 100% automatically, you need an Oracle to handle things for you. So Oracle is like the bridge from on-chain to off-chain. So
Okay.
we need a system, people signing on it, when
Yeah.
in transfer. Uh,
Because
this,
I imagine it's hard to verify, like if the payment has been done or, yeah,
yeah,
like how it's done on
you have to
chain.
find the Oracle that support this.
Yeah. Yeah. And also,
Um,
I think like there's a, I don't know how legal it is in different countries, but last question. Last question is that what is the super simple question? Is what is the advantages of issuing invoices on chain rather than off chain?
I think it's a big problem of the private invoicing. The
Hmm.
invoicing currently is the data will be exposed. So all the information like descriptions, amounts, who is issuer, who is the recipient, it will be exposed and it's very dangerous. So that's why today we do with private invoicing. So we solve this problem by encrypt all the data. So that's the way you can ensure that the data will be on chain and is transparent, but also the data will not be exposed to public. Only issuer and recipient can read it.
Okay, fantastic. And with that, I think that concludes our session tonight. Don't miss this chance to see more resources for you to build your own system. Subscribe to COTI YouTube channel at COTI Foundation, where you're at right now, and set your reminder to join more live streams. Next one will be tomorrow for our Friday night build on building AI agents with pedantic AI. And also August, COTI's show is up if you want to check that out. Thank you very much. Thank you very much, Henry, for walking me through this and bearing with my questions.
Thank you everyone.
All
See
right,
you.
bye.
Bye. Stay cozy.